Welcome back to another video on the channel. Hope you guys having a great day. Before we get started, like, subscribe, hit the notification button, and let's get down to business. Alright, so today we're going to be talking about BTP. And BTP is a Cisco proprietary protocol, also known as VLAN trunking protocol, that is used to exchange VLAN information between switches in the same BTP domain. BTP has three versions, version 1, version 2, and version 3. The only difference between version 1 and version 2 is the version 2 supports token ring VLANs. Version 3 has many benefits. One of them is that you can use the extended VLAN range that goes from 1006 to 4094. And BTP version 3 has other benefits, but for the purpose of this video, we're going to keep it simple. I'm going to do a separate video configuring BTP version 3. But now, let's dive into the BTP modes. So the modes are server, client, transparent, and off. And let me explain. Alright, so first off, server. In BTP server mode, you can create, modify, and delete VLANs and specify other configuration parameters such as BTP version and BTP pruning on the entire BTP domain. BTP servers advertise their VLAN configuration to other switches in the same BTP domain and synchronize their VLAN configuration with other switches based on advertisements received over trunk links. BTP server is the default mode. Client. BTP clients behave the same way as BTP servers, but you cannot create, change, or delete VLANs on a BTP client. Transparent. BTP transparent switches do not participate in BTP. A BTP transparent switch does not advertise its VLAN configuration and does not synchronize its VLAN configuration based on received advertisements, but transparent switches do forward BTP advertisements that they receive out their trunk ports. Off. In the three described modes, BTP advertisements are received and transmitted as soon as the switch enters the management domain state. In the BTP off mode, switches behave the same as a BTP in transparent mode, with the exception that BTP advertisements are not forwarded. So here's what's going to happen. Those three VLANs, VLAN 10, VLAN 20, and VLAN 30, they're going to be configured on their server switch. That server switch is going to distribute those VLANs using BTP advertisements to the first client switch, and he's going to update his VLAN configuration. That BTP advertisement is going to go across the switch that is configured as transparent, which indeed is going to forward that BTP advertisement to the last client switch, and the last client switch is going to update his VLAN configuration as well. Now keep in mind that the only way that this is going to work is if the client switches are in the same BTP domain as the server switch. Now that we covered every single angle in simple words, let's get inside CML and let's get started with the lab. Let's go get it. Alright, so now we're in the CML. We're going to start configuring the trunk ports, and we're going to change the BTP mode in the client switches and the transparent one. Let's get started. Alright, so we're getting inside the server switch. We're going to configure gig 00, interface gig 00, switch port trunk encapsulation.1q, switch port mode trunk. We got that interface already set up. We're gonna do a show IP interface brief. We're gonna do a show BTP status. As you can see, it's in server mode. Let's jump into the second switch, which is the client one. We're gonna hit enable, config T, interface gig 00, switch port trunk encapsulation.1q, switch port mode trunk. An exit there. We're gonna go to the second interface, gig 01, switch port trunk encapsulation.1q, and switch port mode trunk. Hit exit, and we're gonna change the mode to client. We're already there, and we're gonna do a show BTP status. And as you can see, the BTP mode has been changed to client, and we're gonna jump now to the switch, which is gonna be configured as transparent. Type enable, config T. So we're gonna configure here the gig 00 and the gig 01 interface as a trunk, and then we're gonna change the BTP mode as transparent. So just to give you a heads up, we are running BTP version 1. Alright, so the BTP mode has been changed to transparent. And I almost forgot to configure VLAN 40. This is only being configured for the purpose for you to see that VLAN is not going to be advertised to any other switches. It's just going to run on this switch specifically. Alright, let's do a show BTP status. And as you can see, the BTP mode has been changed to transparent. We're good there. Alright, let's jump into the last switch, which is going to be another client. Type enable, config T, interface gig 00, switch port trunk encapsulation.1q, switch port mode trunk. We got an interface configured already. Exit, BTP mode client to change the mode. So we're good there right now. Let's do a show BTP status. And as you can see, the mode has been changed to client, so we're good there. So let's jump into the server switch. We're going to configure VLAN 10, 20, and 30. These are the VLANs that are going to be distributed to the client switches via VTP advertisements. We're going to configure the last VLAN now, which is going to be VLAN 30. Name this accounting. So we're good here. All the VLANs configured already. We're gonna do a show BTP status, and as you can see in the number of existing VLANs, it's 8, and now the configuration revision is 3. Those are the 3 VLANs that we added today as new. As you can see, the first client switch has not received any VLANs from the server, and this is because we haven't configured the VTP domain on the server. So we're gonna jump into that right now. So let's do a VTP domain. We're gonna name it networkjp.net. Alright, so the BTP domain has been changed. Now let's jump into the first client switch, and as you can see, it took automatically the VTP domain that we configured on the server, and consequently he is receiving the VLANs that we configure also on the server side. Awesome. So let's go now to the last client switch, and let's verify and do the same command, show BTP status. So as you can see, the transparent switch forwarded the BTP advertisement to the last client switch, so he's receiving now the VLANs. Awesome. Alright, so just keep in mind that the number of existing VLANs from the BTP output that you see in there is going to be 8, and that's because you're receiving VLANs from the BTP server, and also you have default VLAN configured already in the switch, which is going to be 1, and from 1002 to 1005. But always keep in mind to just verify on the BTP output, the one that says configuration revision. That's going to show you exactly how many VLANs you're receiving from the server switch. So every time that you receive a new VLAN, the configuration revision and the number of existing VLANs is going to change. Be aware of that. So that's going to be all for today. Thanks for watching the video, and I'll see you in the next one. Peace out.